Alright, in this video I'm going to show you how to simplify radicals with variables involved. So we're going to simplify this expression. I'm going to go nice and slow through the problem because this is one of the more difficult things for students to kind of comprehend. So what I'm going to do is, with most things in math, it's used to break things down into pieces that are easier to work with. So what I'm going to do is we have x to the fifth, y to the seventh, and z squared. What I'm going to do is I'm going to break each of these pieces up and deal with each of them individually. So I'm going to have the cubed root of x to the fifth, leave myself some room, the cubed root of y to the seventh, and the cubed root of z squared. And I'm going to deal with each of these individually and then bring everything back together. So here's kind of how the thought process works. I'm going to show you two different ways to think about this. If you have x to the fifth power, so we have a power of 5 on the inside, and we have the cubed root or the third root. What I ask myself is how many times can 3 divide into 5? Or how many times can I subtract 3 from 5? So what we're doing here is we're taking 5 divided by 3, and we're going to figure out what we can divide it by and what the remainder is, the big idea. Or you can think of it as, well, if you have 5, how many times can you subtract 3? Well, you can only subtract it once. So you can only do 5 minus 3 once and you get 2, and then you cannot subtract 3 again until you get into negative numbers. So since you said we can only take away it once, I'm going to write x to the first power. But here's the deal. If you take away 3 from 5, you have 2 left over. Well, whatever the remainder is, we're going to leave that on the inside, and that's going to become the exponent on the inside. So whatever you can take out becomes your exponent for the variable on the outside of the root. Whatever your remainder is attached to the exponent on whatever variable is left on the inside. So if I simplify the cubed root of x to the fifth, I get x and the cubed root of x squared. On this next one, I have the cubed root of y to the seventh power. So again, I ask myself, how many times can I take 3 away from 7? So you can think of it as a subtraction way, or you can think of it as 7 divided by 3, whichever works. So you can take away 3 once, and you're down to 4. You can take away 3 again, and then you're down to 1. So I was able to take away 3 from 7 twice. So since it's twice, I'm going to have a y squared on the outside. And again, on the inside of the radical, attached to my y, I need the remainder there. Well, if I take away 3 twice from here, all that is left over is a 1, so y to the first power. I'm writing to the first power on these now just to kind of show things. If anything's to the first power, you don't have to write it to the first power. And then this third piece, so I have the cubed root of z squared. So I'm going to ask myself, how many times can I take 3 away from 2? Well, I can't take away any at all. So if I can't take anything away, I'm not going to write anything on the outside. So then on the inside, I write what's left over. Well, since I took nothing away, I can't take 3 away from 2. All I'm left with is a remainder of 2. So actually that last piece stays the same. Once I treat each of them individually, what I'm going to do is I'm going to bring everything back together. So what I look at is I look at what is outside my radicals, what's leading out front of my radicals. I'm going to put those together. So I have an x, I'm going to have, there's my x. I have a y squared outside my radical. And I have nothing else outside my radicals. Then I'm going to group together what is left on the inside. So I'm going to have the cubed root. I have an x squared, a y to the first power, which I'm just going to write y, and a z squared. So that would be my answer. And that's probably the most common way most students are going to do this. There is another way to see this problem and kind of the mathematics going on behind it. So I'm going to show this method just in case some of you might be like, well, I don't really like that. Is there a different way? Because some people like things different ways. Well, the thing you have to remember is anything, if you have the third root there, that's the same as taking it x to the fifth, y to the seventh, z squared. But if I want to change it from radical form into rational exponents, that's like taking everything to the 1/3 power. And then what you can do there is, using properties of exponents, this 1/3, it gets multiplied to each of these exponents on the inside. So I have to take 1/3 times 5, which is x to the 5/3 power. Z times, or sorry, 7 times 1/3 is y to the 7/3 power. And then 2 times 1/3 is z to the 2/3 power. So looking at these, what I'm going to do is each of these fractions, these are improper, I'm going to make them proper fractions or mixed fractions. So 5/3 is the same as x to the 1 and 2/3 power. Y to the 2 and 1/3 power. And then z to the 2/3 power. So I just rewrote these as mixed fractions, if I could. Next thing I'm going to do is I'm going to separate the fraction from my whole number. Because again, using properties of exponents, we have x to the first and x to the 2/3 power. Y squared and y to the 1/3 power. Because remember, properties of exponents, if I want to combine these two, I take 1 plus 2/3. Well, 1 plus 2/3 is 1 and 2/3. That's why I can do this. And then I have a z to the 2/3 power. And what we can do is notice all my exponents of whole numbers. I'm going to put all those together. So I have an x to the first, a y squared, and I have an x to the 2/3, y to the 1/3, and z to the 2/3. I'm going to have to continue that up on this next line up here. And what I can do is I'm going to take each of these pieces here, since I have rational exponents there, I'm going to convert them back to radicals. So I still have that x1 y squared. X to the 2/3 power is the same as the third root of x squared. Y to the 1/3 power is the cubed root of y. And z to the 2/3 power is the cubed root of z squared. Since these are all cubed root, cubed root, cubed root, I can put all these together. So I have x1 y squared and the cubed root of x squared, y, and z squared. And if you notice, that's the exact same answer as we got above. So that's just another way of thinking about it. Most students, you'll want to maybe go this route. Other people, maybe they're good with fractions in their previous classes. They want to go this route. This is the more mathematically technical way of why things are working out the way they do. Either way works. So you do whatever fits your style.